The focus of this video is translation in geometry. What is translation? In a plane, a translation moves an object a given distance to the right or to the left and up or down without changing its size or shape. So let us see how. The red figure is the figure which we are going to translate. This figure is, the two of them are together. Now I'm going to move this figure couple units to the right and then moving up couple units. So the new position of the translated image is at point, the coordinate of point A prime is 1, 4. So how many unit the original figure, which is the green figure here, how many unit it has been translated to the right and to the left, or even we can say this original figure was translated up first and then to the right, either way. So that is what we have to find out. So we are going to see the displacement, how many units we can really count like this, because the grid is given, so it is easy for us to count. So this green unit was moved 1, 2, let me switch to my pen, and then 3, 4, 5 unit to the right, and then from here to here, let me change the color. Then from here to here, I'm going vertically up. So 1 unit, 2 unit, 3 unit, 4, 5, 6, and then 7. So the displacement from a green image or object to the red object is vertically we have gone 1, horizontally we have gone 1, 2, 3, 4, and 5 units, and vertically we have gone 1, 2, 3, 4, 5, 6, 7 units. So the displacement from original position to the translated position is given by counting this. Let us try this graphically. Let us try this. So I'm going to move the green one, and you can see it is moving, and it's moving to 5 units and then going up to 7 units. So this is the translated figure. What happens if I change the position? Let me change the position. If it is here and this one is here, let us count this way. It is the same thing. We can see it is 8 unit going towards horizontally to the right and then 5 unit up. If I move these positions instead of going to the right, now if I move my original position to the left of the reflected position, then what will happen? Obviously, then to reach up to here, either I should go up first and then to the left, or we should go left first and then up. So let us see. So the green position is moving 8 unit and then going up 6 unit. So that is how we can do it. What happens if we have the original figure is on top and this one is on the bottom? In that case, we can see what is happening. We are going to the left first and then coming down 7 units. So either way we can do it. Let me move this. We can see that this is what happening, while you can see both of these figures. Now that is what we can find the position like counting the horizontal and the vertical. But the question is, let me move one more time to here. Let us keep it this way. I'm going to move it here to 7 unit, or let me make it 8 unit. And if I can move this down, and let me move this as this one as 6 unit, so 8 unit, and this one is the horizontal displacement is 8 unit, vertical displacement is 6 unit. Now I also have to find out what is the direction of the translation. So means the direction of the translation is the direct displacement from the start point to the end point. Means how many unit is this directly from here to here. So let us see the direction of the replacement. Direction of the replacement is going to be this. So if we change the location of this, let us move this to this point and this to this point, the direction of displacement is going to be different than what we have before. Let me go back to another time, 6 unit that way and 8 units this way. So if we have to find the length of the direct displacement, which is from point A to A prime, we can find this using the Pythagorean theorem. So how we are going to do it? The length of the direct displacement from point A to point A prime can be found using the Pythagorean theorem, which is let me switch to my pen. I will use the red, green, blue. So the Pythagorean theorem we can use as a square plus b square is equal to c square. We know 8, this is, I can use this as a, and this displacement, the vertical displacement, I can use as b. This angle is always going to be 90 degree, so I can use the Pythagorean theorem and I can find the length of this. But the way I have chosen the length, the vertical and the horizontal, it is 6 and 8. Using the triples, we can say that the length, direct displacement is going to be 10 units, but we can use Pythagorean theorem, which is a square plus b square is equal to c square. The use of the Pythagorean theorem is not in the illustration of this video and will be discussed in the related videos. Likewise, this particular diagram or the video, we can also use this for the vector when we are doing vectors. So this video can also be used demonstrating the vector application, which will be discussed later in the related videos as well. So these two things will be discussed later. Now if we the thing is this, we got let me reset the whole thing. We know we can count these because we have this grid line, so it is easy for me to count how many units to the left or right or up or down. But what happens if there is no grid lines? Even then we can find, and we can find using the coordinates. See, the x coordinate is dealing with the left or the right between 4 and -4. We know 4 is greater than -4, so we are going to find the horizontal displacement, which will be the 4, which is the greater value, take away -4. From this 4 we are taking away -4, which gives me 4 plus 4, which gives me 8 units. So that means the displacement is going to be 8 units. If the grid lines are not there, we can count it. Likewise, we can count the vertical displacement. Again, the greater ordinate value or the y value of the 2 points in here is 4. So I will take away 4 from 4. I will take away -2. So that will give me 4 plus 2, which gives me 6 again. So we can do that. I'm going to change these location of these two images one more time, different place, so that we should be able to find out something like this. And let me move this one here. We can see that because the grid lines are given, so we can count. It is going to be 1 unit, 2, 3, 4 unit to the right, and 1, 2, 3, 4, 5, 6 unit up. So if the grid lines are not given, then how we are going to find this out? So let us do it one more time. So now we can see the greater value between these two, the abscissa value or the x value of these 2 points here is 2. So I'm going to, from positive 2, I'm going to take away -2, which is this one. That will equal to 4, and from 3 I'm going to take away -3. That gives me +6. We are also going to use the same application in algebra when we have to find the slope. Rise over run, or change in y over change in x values. But that is also not in the illustration of this video. We can discuss the same thing one more time. Let me reset the whole thing. I'm going to show you the horizontal displacement 4 unit and the vertical displacement 6 unit. It doesn't matter if this point is on the other side, you can still count it. You can see it here. If it is both of them in the first and the second quadrant, still we can count it. So this is the translation in geometry. I hope you understand the illustration, and it will be helpful for you to apply your concept when you're using the translation in geometry.